Hello everyone, welcome to Paymon Tech Media. In this video, you are going to learn how to convert hexadecimal number to an octal number. Hexadecimal number is base 16 number. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. Here we can see to keep the single digits, they used A, B, C, D, E, F, which A hexadecimal number is equivalent to 10 in decimal number, B 11, C 12, D 13, E 14, F 15. So that's a total of 16 different numbers including 0. Therefore, hexadecimal number is a base 16 system. Now let's take a look at octal number. Octal we have 0, 1, 2, 3, 4, 5, 6, and 7. 0 to 7, total of 8 different numbers. Therefore, octal number is base 8 system. We have to keep in mind for every hexadecimal number we have 4 bits, and for every octal number we have 3 bits. Let's see why. So first let's take a look at hexadecimal number and see why we have 4 bits per every hex. So if this is our hex number, this is our binary, and if this is our decimal number. So let's say the range of hex 0 to F. And as I mentioned earlier, for every hex we have 4 bits. Let's put the 4 bits and the place values 1, 2, 4, 8. It's basically 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. Why 2? Because binary, base is 2, and these are the bit position 0, 1, 2, 3, and we get our decimal values 1, 2, 4, 8. Okay, for 0, it's pretty much all the 4 bits turned off. Decimal is also 0. For F, which as we can see here, is equivalent to 15. Let's write 15 here. So which one do we have to turn on in order to get 15? All of them, right? 8 plus 4, that's 12, plus 2, that's 14, plus 1, 15. So all of them turned on. And decimal is 15. Now let's take a look at, let's say, hexadecimal number of 6. Which one do we have to turn on? 4 and 2, right? 0, 1, 1, 0. Decimal is 6. Let's take a look at another D, for example. D is 13, so in order to get 13, which one do we have to turn on? 8 plus 4, that's 12, plus 1, that's 13. And decimal is 13. So as we can see here, for every hexadecimal number, we have 4 bits. Why? Because 4 bits covers all these numbers. If it's 0, all of the bits turned off. If it's F, we have all of them turned on. And if it's any number in between, depending on the value, some bits turned on and some bits turned off. Now let's take a look at octal number. So if this is our octal, our binary here, and our decimal. So the range 0 to 7. 0 to 7. And as I mentioned earlier, for every octal number, we have 3 bits. Let's put the 3 bits value, and the decimal value is 1, 2, 4. Again, this is binary, base is 2, bit position 0, 1, 2. So base to the power of bit position, we get the decimal value here. 2 to the power of 0, 1. Any number to the power of 0, it's 1. 2 to the power of 1, that's 2. 2 to the power of 2, that's 4. Okay, for octal 0, we have 3 bits all turned off. Decimal is 0. Octal 7, we have all the bits turned on. 4 plus 2, 6, plus 1, 7. And decimal value is also 7. Let's take a look at 2, octal number 2. Only 2 turned on, and decimal is 2. Let's take a look at 5. We have 4 and 1 turned on. Decimal value 5. So as we can see, for every octal number, we have 3 bits, because 3 bits covers all, 0 to 7, depending on the octal number, some of the bits being turned on, some of them being turned off. So just remember, for hexadecimal, every hexadecimal number we have 4 bits. For octal, every octal number we have 3 bits. Now let's go ahead and convert one hexadecimal number to an octal number. Let's say hexadecimal number of A, B, 3. First, we need to convert it to the binary. So let's separate them. This is A, B, and 3. As I mentioned earlier, for every hex we have 4 bits. Let's put the decimal values 1, 2, 4, 8, 1, 2, 4, 8, 1, 2, 4, 8. Now A is equivalent to 10 decimal number. So which one do we have to turn on to get 10? 8 plus 2. B equals to 11 in decimal number system. So which one do we have to turn on? 8, 2, and 1. 8 plus 2, that's 10, plus 1, 11. And B is 11. What about 3? 2 and 1. 0, 0, on. So we have 2 turned on and 1 turned on. 2 plus 1, 3. Now let's put the binaries together. 1, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1. Let's double check. 1, 0, 1, 0, 1, 0, 1, 0. 1, 0, 1, 1, 1, 0, 1, 1. 0, 0, 1, 1, 0, 0, 1, 1. And the next step, we have to count right to left every 3 and separate. Why 3? Because we are going to octal number. And earlier we mentioned per octal number we do have 3 bits. Let's count. 1, 2, 3, separate, 1, 2, 3, separate, 1, 2, 3, separate, 1, 2, 3, separate. Now we can put the decimal value for the octal number. 1, 2, 4. 1, 2, 4. 1, 2, 4. 1, 2, 4. Next, we need to add the numbers in the group that is on. In this case, 4 turned on and 1. This one only 2 turned on. This one 4 and 2. This one 2 and 1 turned on. So let's add them together. In this group, 4 and 1 turned on. That's 5. In this group, only 2 turned on. In this group, 4 and 2 turned on. So that's 6. And in this group, 2 and 1 turned on. That's 3. Therefore, hexadecimal number of A, B, 3 is equivalent to octal number of 5, 2, 6, 3. Now let's take a look using calculator. So we have to change the view from standard view to programmer view. And then we want to make sure hex is selected for our hexadecimal number, right? AB3, that's our hexadecimal number. So hex is selected and entering A, B, 3. And here, as we can see, our octal number 5263. 5263. And here we can see the binary as well. So basically, we used binary as a bridge going from hexadecimal to the binary and then converting this binary to octal number. Let's go over another example converting hexadecimal number to an octal number. So let's say hexadecimal number of 7A7. You can pause the video and convert this to an octal number and then double check your answer. So what was the first step? We have to separate 7A7 and then putting 4 bits per every hex, because this is a hexadecimal. Every hex we have 4 bits. This is 7, and then putting the decimal values for this hex. 1, 2, 4, 8. 1, 2, 4, 8. 1, 2, 4, 8. So for 7, which one do we have to turn on? This is off, on, on, on. 4 plus 2, 6, plus 1, 7. For A is 10, right? So we can write 10 here. So which one do we have to turn on? 8 and 2. 8 plus 2, 10. And this one, it's the same as this one. 7, which is 4 plus 2 plus 1. that's 7. So here we got our binary number. Let's write down our binary here. 0, 1, 1, 1, 1, 0, 1, 0, 0, 1, 1, 1. Double checking quickly. 0, 1, 1, 1, 0, 1, 1, 1. 1, 0, 1, 0, 1, 0, 1, 0. And then 0, 1, 1, 1, 0, 1, 1, 1. Next step, we have to count right to left every 3 and separate, because we are going to octal number. So any octal number, we have 3 bits. Let's count right to left. 1, 2, 3, separate. 1, 2, 3, separate. 1, 2, 3, separate. And 1, 2, 3, separate. Next, we have to put the decimal values for the octal number. We have 1, 2, 4. 1, 2, 4. 1, 2, 4. 1, 2, 4. You might say, what's going on? Why here we have 1, 2, 4, 8? 1, 2, 4, 8. Here we have 1, 2, 4, 1, 2, 4. Because here it was hexadecimal, and per every hex number we have 4 bits. So the decimal values 1, 2, 4, 8, 1, 2, 4, 8. Now when we get the binary and converting to the octal, so we have to separate by 3, because every octal we have 3 bits. And we have the decimal values for the octal 1, 2, 4, 1, 2, 4, 1, 2, 4. So here we have 2 and 1 turned on. In this group we have 4, 2 turned on. In this group we have only 4 turned on. In this group, all of them turned on. Okay, so here in this group we have 2 and 1 turned on. 2 plus 1, that's 3. Here we have 4 and 2 turned on, which is 6. And here only 4 turned on, that's 4. And all of them turned on, that's 7. 4 plus 2, 6 plus 1, 7. Therefore, 7A7 hexadecimal number is equivalent to 3647 octal number. Let's take a look using calculator. So changing the view from standard view to programmer view and making sure hex is selected, because this is our hex number, right? So making sure hex selected, 7A7. And we can see for the octal number 3647. And as we can see here, 3647. This was a quick overview of how to convert hexadecimal number to an octal number. If you have any question, please leave it in the comment section. If you like the video, please hit the thumbs up. And to see more videos like this, please subscribe to our channel. Thank you for watching and have a good day.